Welcome to the NPI webinar in the Xpedition VX webinar series. I'm Julian Coates and will be taking you through the lean NPI flow based on our latest software releases, a solution that brings better NPI results both for you as a designer and for your manufacturing suppliers. First, what do we mean by new product introduction in the context of PCB design and manufacturing? The essential point is the transition from the design domain, where the primary focus is creating the model of the product, to the manufacturing domain, where the main focus is defining and running a suitable manufacturing process that results in high quality, lowest cost production. Between these two domains of product definition and manufacturing process execution stands the NPI stage, comprising the product NPI stage, where the designer's product is validated as being compatible with the intended manufacturing processes, and the process NPI stage, where the precise manufacturing process for a particular product is defined, including the creation of all execution-ready documents and programs for use on the factory floor. During this seminar, we will summarize the essentials of DFM and its significance for the designer. Then, we will explain our recommended best practice for the most efficient way to hand off a product design into the manufacturing process, a method we call Lean NPI, which naturally leads us to show the NPI highlights of the VX Xpedition release, which are the combination of DFM embedded in the Xpedition designer's desktop, followed by comprehensive preparation of the manufacturing level product model data for fastest and most automated introduction into manufacturing process preparation. You probably saw this in the Xpedition VX overview webinar. Well, a major aspect of VX Xpedition is how the layout designer can prepare his product from the DFM standpoint, reduce manufacturing related revision spins, and free up the NPI engineers to focus on preparing his product for the manufacturing process. Overall, better for the designer and better for the manufacturer. Consider that if you are a PCB designer, probably you recognize some or all of these challenges. So for example, how do you manage the handoff to prototype manufacturing? Do you get working prototype boards into your hands fast enough and built as you intended? When you switch from prototype to volume production, are unexpected engineering changes required? Do you get the same product as you got from the prototype manufacturer before? How to take more control over manufacturability at the design stage without having to be a deep domain expert in manufacturing processes. Before we move ahead with the new NPI functions in the Xpedition flow, let's take a few minutes to look in a little more depth at the traditional NPI flow that you have probably experienced or observed in the past. You may recognize some of the steps from your own situation. The roles are divided between the design organization, the ultimate owner of the product, and the various manufacturing organizations. Here we first show the prototype PCB manufacturer. The roles may be integrated within the same organization or distributed across independent companies, depending on the degree of manufacturing outsourcing. The designer lays out the PCB and then generates the traditional set of documents and data files for delivery to the prototype fabricator, who then reintegrates all that data back into a single product model in the CAM system. Often at this stage, there are requests for further information from the manufacturer who wants to be absolutely sure that he's working with a complete and correct model of your product. Following any necessary clarifications, the fabricator will run a DFM analysis of your product, which may give rise to requests for engineering changes so as to achieve acceptable manufacturability. This in turn gives rise to another set of documents and drawings for reintegration in the CAM system, and assuming no further clarifications or engineering changes are required, the fabricator can make final verification with you that he has entered data from your drawings correctly. For example, if an assembly panel drawing has been issued, after which process preparation for fabrication can proceed, and in parallel the data and documentation for the assembly department can be compiled and delivered to the assembly NPI department. Then begins a similar sequence with the assembly NPI engineer, during which the product model will be reintegrated on the assembly side, including this time integration of the bill of materials and approved vendors list, and, following any necessary clarification and engineering change cycles, the assembly NPI engineer can proceed with process preparation. As the project moves from the prototype stage to volume production, additional manufacturing service providers will go through similar cycles of product model reintegration, DFM analysis, followed by requesting engineering changes, which not only causes further delay and cost escalation, but also the risks to quality increase as a result of so much product model reintegration work taking place at the manufacturing level. The result of running such an NPI process across multiple manufacturing suppliers can be unwelcome delays and cost increases coming from the multiple clarification and engineering change cycles, made worse by the inherent quality risk associated with the extensive and inevitably variable product model reintegration work taking place across your manufacturing supply chain. Maybe some of all that is familiar to you. It is probably worth asking yourself what some of the key metrics are within your own NPI process. For example, how much time do you spend answering questions from the manufacturers, and how much time do they spend working out which questions to ask? How many design revision spins or engineering changes do you go through when the product is already handed off to a manufacturer? The industry average for companies who do not use DFM analysis at the design level, when last surveyed, was 2.8 revision spins per design. By contrast, here is a more integrated NPI process. In fact, mentors recommended best practice NPI flow until today. Key aspects of our recommended NPI flow are the left shifting of DFM analysis rules to a unified product-level NPI function in the design organization, running concurrently with the PCB design operations. The NPI engineers in fabrication and assembly who manage their DFM rules in relation to their manufacturing processes feed their rules to the NPI specialist at the design level, who manages them for use concurrently with the layout process. The result is the preparation of a single integrated ODB++ product model ready for final verification and handoff to the fabrication and assembly NPI departments. Because the product model has been prepared using the manufacturing process rules of the manufacturers, the frequency of delays due to the need for clarifications and engineering changes is reduced. You as a designer get your product manufactured faster and more exactly according to your requirements, and the manufacturers can focus their resources on their core competence of preparing and running the manufacturing process. Indeed, this lean NPI process flow scales across multiple manufacturers, thus accelerating not just the prototype phase, but also the transition into successful volume manufacturing. Key aspects of the flow are verifying at the design stage that the product is manufacturable by all your suppliers with acceptable first-pass yield and cost, followed by handoff of a single integrated product model to the manufacturing process engineers for consistent manufacturing by any or all of your approved suppliers. Building on that, with the release of Xpedition VX, we are announcing additional significant steps in further consolidating the NPI flow between Xpedition design and the PCB fabrication and assembly processes. DFM verification is now embedded into the designer's Xpedition desktop, enabling designs that are right first time in terms of manufacturability, yet without requiring the designer to become a manufacturing expert. The DFM rules are managed on the designer's behalf by the product NPI expert, who manages the DFM interactions with the manufacturers and preparation of an even more integrated product model based on the new version 8 ODB++ format. The result is a significant enhancement of Mentor's best practice NPI flow, bringing further cycle time savings, higher levels of embedded quality, and lower total NPI cost. The Lean NPI solution in the Xpedition VX flow comprises two essential aspects. The first aspect is the maximum left shifting of DFM analysis into the PCB layout process. It is a generally accepted rule that the time and cost impact of identifying the need for and implementing an engineering change to a product design increases by 10 times with every step taken in the life cycle of the product, from design to NPI, prototype, and then volume manufacturing. Thus, identifying and implementing engineering changes early in the product lifecycle can bring substantial cost and time savings in the course of bringing a new product to the market. By gathering the rules from manufacturing and applying them during the layout process in Xpedition VX, you will experience a new level of total cost reduction and speed in the successful launch of your products. But of course, it has to be easy for the PCB designer to do, along with all the other concurrent tasks he has to handle. In the next few minutes, we will run through in more detail what we mean by manufacturing rules and how easy they are to apply within the new Xpedition VX flow. The second aspect of Lean NPI is the use of intelligent, integrated product model data for handoff to the process NPI stage. By preparing a single product model that is DFM validated and does not require reintegration by the manufacturers, a range of benefits are achieved in the NPI stage, including time savings in both product and process NPI stages, a reduction in the risk of mistakes and misunderstandings, and higher consistency of product across multiple manufacturing suppliers. The probability that you will get the product you intend will increase if you take full control of the product model in your own NPI operations, rather than leaving it to each manufacturer to define for themselves based on how they interpret multiple files and documents. During this webinar, we'll be looking more closely at the V8 ODB++ and its full scope for supporting a more automated NPI flow. But let's take a closer look at DFM and the Xpedition best practice for maximizing the left shift. The key point about DFM analysis is that the rules to be applied should relate to the manufacturing processes that will be used when manufacturing the PCB. This is why DFM is not the same as the application of design rules, which relate to the product design more than to the manufacturing process. Examples of manufacturing processes are, for fabrication, the drilling process, etching and galvanic plating processes. For assembly operations, key processes include solder paste printing, placement, reflow and test. There are many additional processes to consider, but when taken together from your prototype and volume manufacturers, you are in a strong position to left shift DFM into your design flow. After applying the manufacturing process rules to the model of your PCB, the manufacturing process hazards are presented back to you according to the severity and the manufacturing process that has a compatibility problem with the product as currently designed. Notice that the DFM analysis results are not presented as go, no-go like design rules checking. Manufacturing process is all about percentage yield and degrees of quality and product reliability. Thus the results are presented according to severity from cannot manufacture to fully okay, with opportunities to improve yield in the yellow zone between. For example, it could be that the yellow results are okay for the prototype manufacturer, but would be a barrier to successful ramp to volume, so the application of the rules enables the designer to manage the progress of his product all the way to volume production, in fact the full NPI lifecycle. So let's see Valor DFM technology running embedded within the designer's Xpedition desktop. The designer chooses the DFM rules that have been prepared for him by the NPI engineer and initiates a DFM analysis of his design. The fabrication analysis results are reviewed within the hazards interface where you see the red, yellow, green classifications. The first hazard is a violation of the etching process rules. The designer designs out the fabrication hazard and moves on to the next DFM problem, which is also a violation of the etching process. The third example is a sliver, which brings the risk of low yield or random open circuits in manufacturing. Then we see an area in the design where there is a risk of incomplete solder reflow, also known as dry joints. By adjusting the thermal reliefs on the inner layers, fully reflowable solder joints are achieved. Lastly, another solder process problem with silkscreen ink partially covering the pads. It will be impossible to achieve complete solder coverage this way. With Valor DFM technology embedded within the Xpedition VX desktop, the PCB designer can achieve a high level of DFM compliance before handing off to the NPI team. In summary, you have seen how the Valor DFM technology embedded in the designer's Xpedition VX desktop offers a range of fabrication analysis checks that deliver high value and where problems can be fixed easily within the Xpedition system in a way that is clearly understandable within the Xpedition interface. The DFM rules are managed on the Xpedition network by the NPI specialist for the benefit of all the Xpedition layout users, integrating DFM into the design process, but without calling for the layout people to suddenly become manufacturing experts. It all connects to the emerging trend in electronics design to concentrate more functionality on the desktop of the engineer designer. In the end, it's much better to find and fix DFM problems at source, rather than wait for the NPI team to find them later at greater cost in time and money. We now move on in the flow to the product NPI phase that is supported by the Valor NPI product. We will begin by looking at the product model data that is handed over to the NPI flow. Here you see the Valor NPI interface. A lot of useful data about your product design is extracted from the Xpedition system to be carried through the NPI flow. For example, you see here all the information that is normally seen in drawings and documents, but here it is stored as structured data, part of the manufacturing level product model. As the NPI flow unfolds, the NPI engineer can add more information to the product model, further reducing the dependence on documentation and reducing the potential for human error. For example, additional information about the thickness of the PCB and how it is to be measured. And here is the enhanced layers matrix in the V8 ODB++, now holding dielectric materials and copper weight specifications, thus eliminating the need for stack-up drawings. A complete definition of every drill object is embedded, carried directly into the NPI flow from Xpedition. For the components data, a wealth of placement and component properties information is held, as structured data useful for driving the NPI software processes. All of this information, both at the single feature and summary levels, eliminates the need to generate and manually interpret drawings, while at the same time being instantly available for automated software processes. Now we look at further left-shifted product NPI work that can be completed before handoff to the manufacturers. We start with a full validation of the assembly and test processes, taking into account all possible purchasable parts on the approved vendors list or master parts list. Valor NPI is launched and the list of parts is accessed from the data passed across from Xpedition. Then all the purchasable part numbers that may be used by the manufacturers is accessed, and the package and pin models imported automatically from the Valor parts library. You see here all the package types and lead forms that will connect with the DFM rules to be applied. Here you see the difference between the Xpedition library representation of a part and the Valor parts library representation, including precise outline and the pin contact area on the copper pads of the PCB. For each design library part, there can be multiple commercial alternatives. Valor NPI analyzes all combinations of alternative parts and their impact on the manufacturability of your design. For example, here is a mismatch between component pins and the land pattern. Cross-probe back to Xpedition to fix the problem at source. All combinations of supply chain parts are verified, so giving your manufacturers maximum flexibility when procuring materials. The Valor NPI analysis checks not only for assembly process compatibility, but also your ability to gain access to all test points for maximum test coverage. As with Xpedition embedded DFM, manufacturability is optimized by fixing the problems either in the Xpedition system or in the master parts list or AVL. We have just validated that the supply chain data in the AVL or master parts list is compatible with the product design and vice versa. The manufacturers have maximum flexibility in their materials procurement, and you have minimized the chances of late-stage engineering or AVL changes after the product gets into manufacturing. The last step in preparing the product model for handoff to manufacturing is the assembly panel. This is the exact definition of what the fabricator delivers to the assembly manufacturer for processing. The engineer selects the design and creates the assembly panel. The step and repeat and rotations are defined, after which a rapid DFM analysis is performed to check that there is nothing wrong with this configuration before proceeding further. But in this case we discover a DFM violation between two components that protrude outside the PCB profiles. By adjusting the step and repeat data, the problem is designed out of the panel. Now the detail of the routing and V-scoring is defined. Fiducials are added with their attributes. Then tooling holes are added. Any text that is required can also be added into the panel at this stage. And then copper balancing is added according to preset rules. When all is defined, a final complete DFM analysis check is then run on this final product model, and when all is confirmed as OK, it can be saved and exported and handed off to manufacturing. What you have just seen illustrates how by building the assembly panel in data, the need for the assembly panel as a drawing has been eliminated. No need for the fabricator to read the drawing, enter the data, reconstruct the panel, or engage in clarification and sign-off cycles. In the end, it is all about you, the design authority, fully controlling the definition of what will be manufactured by all your manufacturing suppliers. We have now covered the product NPI flow, starting with DFM verification embedded in Xpedition, through to comprehensive product modeling and verification, bringing us to the point where we are ready for handoff to the process NPI phase, where the execution-ready manufacturing processes will be generated. The manufacturing level product model is ready for handoff, comprising a complete definition of the PCB to be fabricated, assembled and tested. Instead of an assembly panel drawing, we have a complete model of the assembly panel in data. Instead of a parts list and assembly drawing, we have all the components data, their attributes, positions and rotations defined in the data. The drill drawing is made obsolete by the drill tools data that is embedded. Fabrication notes, typically found on the fabrication drawing, is covered by feature attributes defining requirements such as surface finish and controlled impedance features, together with the summary data. The stack-up drawing data is included in the ODB++, shown here with examples of the dielectric requirements, including bulk resistivity and loss tangent for the insulation layers, and the copper weights for the conductive layers. When a complete product NPI process has been carried out, there is much more to the ODB++ than being an alternative to Gerber. Instead, it delivers a complete definition of what has to be manufactured, including all of the information traditionally carried in paper or PDF documents, but now integrated into the structured data ready for immediate and automatic use by the next software tools in the flow. But how can you be sure that the ODB++ data is really optimal for getting your product manufactured? Well, take a look at what the manufacturing process engineers do with it. First, we will take a look at how a leading PCB fabrication tooling system, such as InCam from Frontline, runs when starting with a fully prepared ODB++ data package. Here you see the user interface in InCam, where we start by loading the ODB++ data into the database. To begin with, you immediately see that there is the single-step version of the PCB and also the assembly panel. The assembly panel is there in its complete form, exactly as defined earlier by the product NPI engineer. A closer look at the layers and matrix structure shows that no aspect of the product model has been lost in the handoff to manufacturing. The route profile and V-scoring data is there, ready for conversion into process-compensated machine programs at a later stage, as is the drilling data, with all the information included for automatic generation of right first time drill programs. Every drill hole data object carries the attributes about whether it is plated or unplated, whether it is a via or a through hole, plus the required final plated hole size and tolerance. The summary data is there in the database of the CAM system, ready for use by the engineering software, much better than being stuck as a statement on a piece of paper. Here we see overall thickness data and further multi-layer stack-up information. Surface finish definitions are defined and can be highlighted immediately for use in the tooling generation process, as can controlled impedance features. The process engineering specialist will always want to run his own DFM analysis, taking advantage of the intelligence in the ODB++ data, so as to validate manufacturability, but also to maintain the rules according to the actual manufacturing processes running in the factory. These automated stages take us quickly to the generation of the manufacturing process data itself. Here we see the creation of the panel that will go through the fabrication process. Notice that the most efficient material utilization in fabrication for this particular fabricator is achieved by placing 4 assembly panels into the fabrication panel. All that remains then is to generate the various machine programs for the manufacturing processes, taking full advantage of all the embedded intelligence in the database. Now let's see ODB++ supporting the assembly and test stage of process NPI. As before, the first step is to import the ODB++ product model, where you see the layers of the PCB relevant to assembly and test, with all layers stored in the database. All the rich component data is there, together with the embedded netlist. Bill of materials is according to what has already been integrated and verified. The assembly panel is there exactly as it has been fabricated. For example, the fiducials are recognized. The routing and V-scoring is there for singulation programming. The first stage of process NPI is to define how the product will be assembled with allocation of parts to the different assembly processes. Straight to machine programming, supported by machine-level library data and the VPL. The solder stencil is generated as part of the process, derived from the process and product models. The output is then made to the stencil manufacturer. For the test process, first the test files are confirmed according to the tester selected, verified, and then exported as a machine-ready test program. Lastly, the moment has arrived when it is relevant to generate process documentation for the factory floor. The rich product and process models enable automatic generation of the correct documents for the selected process. Altogether, a complete execution-ready manufacturing process. That brings the Xpedition Lean NPI webinar to a conclusion. Today we have shown how, in contrast to the traditional NPI flow that is characterized by cost increases, quality risks and delays, a far better lean NPI flow is available based on proven Valor technologies. The Xpedition Lean NPI flow starts with maximizing the benefit of left shifting DFM onto the Xpedition designer's desktop, enabling the designer to minimize manufacturing related revision spins at source, but without having to be a manufacturing expert. Following that is a comprehensive product NPI operation based on the Valor NPI platform that completes the left shifting of all aspects of DFM and provides an efficient handoff to process NPI for right first time introduction to manufacturing, fast ramp to volume, and with maximum flexibility in the supply chain between all your fabrication and assembly suppliers. As you will have seen, Lean NPI is a flow-based solution for a business process that extends across design and outsourced manufacturing operations. Every participant in the flow can state that it is better for me, but also better for you, my partners in the process. This webinar is one of many in the Xpedition VX webinar series. We hope you will benefit from the others in the series, for which you will receive notice by email. Review them at your leisure, and if you have questions, use the email address shown here to talk with the experts. Thank you very much for your attention.